Here we are with a slightly different, I'd say a very unique question here about electric current. So this is from B5, all about circuits and current. Have a look and then we can see where the answer comes from. Okay, so I think the thing that's different about this one is that, and again I noticed that IB does this quite a lot, is that we've got some new quantities being introduced here, and I've seen this in multiple different papers. In this case, we've got things about uniform charge distribution. Okay, now charge distribution is not something which you are necessarily expected to learn in lessons. However, it's something that you should be able to kind of think about. And so in this case, you've got 5 millicoulombs per meter squared. So what that means is every meter squared has got 5 millicoulombs on it. Okay, so I think once you know or you can understand those words, you're probably okay. However, I can imagine students being a bit confused here because it's not a concept that you learn directly in class. Okay, we're being asked here to calculate the current, and so a starting point here for us would be to think about, well, the equation for current, and that's the rate of change of charge, the rate of flow of charge past this particular point. Now what we're going to do is we're going to say that the charge here is going to be my charge distribution, or charge density if you like, times the area. So we're going to take this 5, I'm going to represent it with a sigma, okay, and multiply it with an A. I'm going to recognize that I've tried my best here to match the shape. My area is this rectangle, I suppose. It's looks differently because of the perspective there. And so we have got a dimension here, x and y. Now we know the dimension y, that is the 0.6. However, we don't know x, but we don't need to know it. Why? Because we're going to put our charge, which is now distribution, our density effectively, times x times y. And we're going to put that straight into the equation. And hopefully what you see here, and sorry it's a little bit small on the screen, delta q over delta t. Well, we've effectively got delta x over delta t. There's missing a delta here. Now delta x over delta t is simply the speed of the belt. We're told that that is 2.5 meters per second. So if we want to get the current, we simply need to take the charge density times that dimension in the y times the speed. Okay, and what we're going to do there is remember that we've got a 5. Now you notice all of the answers here are in milli, so we do not need to change this 5. We can keep our answers in millis, times 0.6 times 2.5, and we get an answer here of 7.5, which is why the answer here is B. And like I say, I think the question here is more about your understanding of how to take a new concept and apply it to something that you are relatively familiar with. And I've noticed that charge distribution comes up. I've definitely seen a paper 2 question before where they talk about charge distribution, and I'm sure it will come up again, so it's always a good one to have in your back pocket.